When you think of water scarcity, you might picture vast deserts or the arid landscapes of the Middle East. But what if I told you that countries like Indonesia and Sri Lanka, both blessed with abundant rainfall, are still facing a severe water crisis? Despite receiving more than 2,500 millimeters of rain each year, millions of civilians struggle to access clean and safe water. This paradox is echoed throughout many countries in the global south, where the challenge isn't the absence of water itself, but the lack of infrastructure and process of sanitation. Now, keeping this in mind, we'll dive into our project concept with the objective of achieving Sustainable Development Goal 6, while simultaneously exploring why, in a land where rain is plentiful, so many are still without reliable access to safe drinking water. Hi, I'm Sarah Saeed.
And I'm Ahmed Kumayl.
And I'm Daffa, Reinaro,
And we're here to present our Project C Squared.
a simple yet effective product that addresses the lack of clean water in LEDCs. We've utilized the concept of microbial fuel cells, which uses the work done by microorganisms in order to generate electricity and water.
In this system, the anode chamber houses bacteria, which feeds on biomass and undergoes aerobic respiration to allow for hydrogen to be produced. Oxygen circulation is done in the cathode chamber, which allows for water to be produced.
Here's the equation for this concept.
Bacteria can be found from mud and dirt anywhere, which makes this concept so accessible for all.
An ion exchange membrane between the cathode and the anode prevent unwanted reactions from taking place on the wrong side of the system. The result is self-sustaining product that produces electricity and clean water.
Now you may be wondering, where does all this electricity go?
A lithium battery stores all this electricity. An embedded system monitors crucial factors about the water, such as pH level, temperatures, and other similar factors.
Now to top it all off, the final product, including the screens and the monitors, amounts to less than $15. Now that's $15 for a self-sustaining and long-term solution to clean drinkable water wherever you are.
So here's what C squared really is. On the screen, you'll see a blown-up diagram of a 3D rendered design concept. Highlighted in blue is the container, whilst in white is the capsule and the lid, all of which will be made out of reused plastic. The capsule is split into two parts, using the membrane, which is highlighted in yellow. The cathode side of the capsule has two vents. The first vent, which allows oxygen to enter in and chemically bond with the hydrogen, generating water. The second vent allows for this generated water to filter down into the bottom half of the container. The two cathodes are wired up to a battery which is housed on top of the lid, and this battery can be used to power the supply and the LCD screen. The membrane is probably the most important part of the system. It's a Nafion ion exchange membrane which allows hydrogen molecules to pass through the membrane. This hydrogen, which is produced at the anode side of the cell, has a small atomic mass, which is why it can pass through. However, oxygen molecules, which are bigger at a molecular level, cannot pass through, which is really important because we don't want the oxygen to pass through onto the wrong side of the system and react with the hydrogen and corrupt the current and the electric components of our system.
The monitoring system consists of a set of sensors and a program that runs together to monitor certain aspects of the water. An open source platform known as Arduino is in charge of interlocking the hardware to the software, enabling the coded program to understand the outputs given by the sensors to then act upon. The program shown on the screen is a simplified version of the code that would actually be input. It has various functions, each intaking its own parameter and outputting the required message on the LCD screen based on it.
This monitoring system is not essential. In fact, it's optional, and the product works fine without it. But the monitoring system tells us information and crucial details about the water itself, which can be extremely important for the users, such as pH and temperature.
As previously mentioned, our microbial fuel cell system uses locally available bacteria to break down organic matter, producing water and electricity as a byproduct.
This means that the raw materials needed for the water and electricity generation aren't just accessible. They're often waste products that communities around the world have an abundance of.
And this is why our solution, C squared, otherwise known as clean current, is the most effective and best method to tackling SDG 6.